So in this video, we're going to be reviewing for the benchmark, the Unit 1 benchmark, and we'll be using the practice benchmark that I gave you for this video. There may be more emergency reviews with more examples, but I'm going to do this one like a little shorter review. So we'll just stick to the practice benchmark assignment that we have here. First off, you have to measure this line segment. So you want to make sure that you know how to do that using a ruler, using centimeters. If that's a problem, definitely come talk to me about it. But we'll move on to this next issue. We'll start even on number 2. So, you know, it would be good if you had a ruler, but if not, we have some that we could share. Okay? On this problem, we should understand that, you know, we need these two pieces to add up to 17, right? That from here to here is the missing length, and we know that they make a straight line. And so if this piece is 5, we should be able to know that the answer here should be 12, right? Because 5 plus 12 makes 17. So that's what's going on in this one. Okay? Now for this example, we have, again, a description instead of a picture, a diagram, right? So you're going to have to draw your own diagram in the case that you can't visualize this in your head. Obviously, if you can see this in your brain, then this might be fine that you can do it that way. But otherwise, we should understand that this idea of B being between A and C, okay, and that A, B, and C are collinear points, okay? So collinear means that they're on the same straight line, right? So if I have a straight line segment like this, and I call that A and C, then we know B has to be somewhere in between them, okay? And so after this, it tells us a couple things, right? It tells us to find AB, okay? So understand that that means it wants us to find this little distance right here. We can put an X there if we want, okay? And then it tells us the whole length is 23. So the whole length from here all the way to C, that whole length again is 23. And then it tells us that BC, this piece of the line from B to C, is 11, okay? So we should be able to understand what's going to happen, right? That we know that because AB plus BC equals AC, right? The line segment addition postulate, well, that means that X plus 11 must equal 23. And therefore, if I subtract 11 from both sides, right, we'll end up with the final answer of 12, right? So we can subtract 11 from this side, subtract 11 from that side, and then we end up with X is equal to 12, which is our final answer, okay? And then we can go label our picture, and we could think about whether or not this makes sense. Does this make sense? The 12 plus 11 is 23? That makes perfect sense, right? So again, this problem shouldn't take too long. I don't want to focus on it for too much time, but you should maybe draw a picture if you're a little stuck there. Okay? Then we want to understand what the difference is, right? So acute angles are angles that are less than 90, and obtuse angles are greater than 90, okay? So we'll just go write that down and make sure that you guys can understand, right? Acute, okay, less than 90, right? That's what acute means, okay? Whereas obtuse means more than 90 degrees, okay? Whereas a right angle is exactly 90 degrees, and a straight angle is 180. A straight angle is just a straight line, okay? So in this problem, we should have C, that is an acute angle. That's what we get right there, okay? Then we go move to number 5. All right, number 5, make your choice, okay? This angle looks bigger than a 90-degree angle, so we should have obtuse in this case. Okay? In this case, we want to understand that interior means that a point is inside, on the inside region of an angle, and exterior means it's on the outside, okay? So if you don't understand this, we should talk about it, but I'm hoping this is self-explanatory, okay? So we would say that the point P is interior in this example, and in this example, number 7, it's exterior, okay? So now as we look at this example for 8, we should recognize that we have to label the picture with some numbers. Okay, so I have been telling you guys, on any problems like this, our steps were read, label, and think. Well, the first part that we want to understand is RSD is 87. So I'll go highlight that. RSD, 87. Okay. And the next one, DST, is 91. So we'll go to D, then S, and then T. Okay, so that angle is 91. Okay, so again, we read the problem. We put some things in there. We labeled it, so we're done with that, and now we got to think. Okay, well, if we forget to read it, we might not know what we're doing. Okay, and it tells us to find RST. So again, don't forget to read the problem at every step along the way. When you do little middle steps, sometimes you got to go back and read the problem again. Okay, so RST is again this whole angle, right? If we go change this color, we could see that RST, if I start there, you see the yellow angle is the whole thing, okay? And it's not necessarily a straight line. It's just pretty close, okay? So recognize if I want to get the whole angle, I have to add up those two values, right? I have to do 87 plus 91, okay? And that will give me 178 degrees, okay? So this whole angle, again, that whole angle is 178 degrees, and that's the idea, what we're looking for here, all right? So you could do the next one with a similar format. What you'll have to do here is just make sure you read, label, think, and then figure out if you have to subtract or add. Okay, in this case, we should see that JIH is the whole angle. That's 146. And JIC is this one little piece that's 100. So that means this piece must be the 46 that's left over so that they can add up to a total of 146, all right? So read, label, think on those problems, and you'll be all right. For number 10, we're testing on vocabulary here, okay? So in this case, we would call this one a linear pair, okay? A linear pair of angles is when we have two angles that are adjacent to each other on a straight line, okay? So we just call that a linear pair. It's a definition we've been working on for a while, okay? These are complementary angles, okay? When two angles add up to 90, we call them complementary, and when they add up to 180, we call them supplementary, okay? So here we'll use the word complementary, and that's fine. Okay, notice the directions don't contain complementary, so sorry about that. I'll fix that on the next version. Okay, these two angles are opposite from each other at this vertex, and so we talked about how that is the definition of vertical angles, right? So you guys should be able to see that this one is vertical angles, all right? Now again, we notice that vertical angles, one word that makes them vertical is actually not that they're going up and down or left to right. The idea of the vertex is what it is, right? These two angles have the same vertex, but they're not just adjacent to each other, they're opposite from each other. So they got to be equal, okay? So again, think about that. These vertical angles have the same vertex. A and B are equal to each other, okay? In this case, we have the idea of exterior angles, right? Both of these are exterior to the parallel line. So don't forget, that's what we meant by exterior or interior, right? For them to be either one, they both have to be inside or they both have to be outside. So in this case, they're both outside, so that's exterior. And because they're on alternate sides of this line called the transversal, all right? Because of that, we know that they're alternate exterior, okay? So that's what you guys should have on this one. Okay, now for 14, again, we want to know that these two angles have to add up to 180. We're assuming this is a linear pair by looking at it because we haven't been given any more information. So when we're not given anything else, we know that this should just be a straight line, okay, from the context here. And so this has to be 139 degrees or we won't get 180, okay? So one way to solve it would be 180 minus 41 gives me 139. Okay, for 15, I got a couple problems, questions on this today. People kind of forgot how we talked about that a full circle is 360, okay? So do not forget that we talked about that for a while, right? Why did we have this system of angles, right? That 360, right, takes us around a full rotation, right? So we know that the degree system works that way, right? It's 360 of them that make a full circle. So just use that idea. You would have to understand that these three numbers should add up to 360, and we would want to pick the number from this list that gives us 360. All right, so in this case, you'll get an answer of 26. All right. Now, don't forget, you guys have all the answers with this, and I know we might need some more practice if you guys are really nervous about your score. So we'll talk about what we could do for that later too. Okay, these are complementary angles, so these two should add up to 90. So again, we should know right now that this should be 29. Okay, now 18, these are alternate interior angles. So you should be able to walk up to this problem and know after about maybe 30 seconds at most that this is 67, that those have to be the same, okay? I have been trying to emphasize to my students that all you need for parallel lines, and again, go back and watch the video on parallel lines where I focus more on that if you need to review this topic, because it'll probably be worth it, okay? But I try to say, if I know that two lines are parallel, okay, and I know that one of these angles is 80, if I knew that, then all the other angles are also set up, okay? Because this would have to be 100, right? So that they could add up to 180. So now notice that there's really only two different numbers that occur in this diagram of parallel lines, right? So what we want to do is be able to look at this picture and know what the relationship is, right? If that's 67 and this one, we should recognize that those two have to be equal, okay? And remembering this picture, memorizing this, could help us visualize it, okay? So I would highly recommend doing that if you're on these problems. If they don't seem that easy and you need something to remember, draw this when you start the problem, and that'll kind of refresh your memory, hopefully. So now as we go through number 19, we'll see again we got corresponding angles here, okay? So those are both on the bottom left, right? This is on the bottom left up here in this area, and down here in this area, this one's on the bottom left, so we call those corresponding. So if these lines are parallel, those angles have to be equal, so we should have 117. Okay, for 20 now, we get this idea where this is going to be a multiple point problem, so this one will be worth 3 points, and you'll have to show your work to get credit for this, okay? But the idea is that we should see that these two are not equal, okay? Notice that this one is acute and that other angle is obtuse, so in this case, we want to know that those are same side interior angles. And what this means is that these two angles, right, they have to add up to 180. Okay? So, I hope you guys can see what I'm trying to show you right now. Okay? The red one, this one, plus this one. Okay, these two have to add up to 180. Okay? When they're on the same side interior, that's what we need. So, you can solve through the algebra by adding the 8x with the 5x, that's 13x, and then 19 plus 5 is 24, and this is all equal to 180. So then we just want to do some algebra to solve the problem. So we'd want to subtract before we divide here. So we'll end up with 13x equals 180 minus 24, which is 156. And now if I just divide both sides by 13, we'll be finished. And we'll see that x equals 12. Okay, so we can find the answer is right here. Okay. You can also substitute this value in and then double check to see that it works, right? If I do 12 times 8 and then add 19, and if I do 12 times 5 and add 5, we can double check to see that those numbers actually add up to 180. All right. I won't do that here in the video, but you can always do that on your own when you're working. Okay. So like I said, show your work on that problem. That's a multiple choice one. And we're doing pretty good here, making decent time, 13 minutes so far in this video. So in this one, we have this idea of a bisector. Okay, we wanted to make sure that you guys understood angle bisectors. Okay, the word bi means two, and sector means pieces. Okay, regions. So what this means to cut it in two is we mean to cut it into two equal pieces. Okay. So what we see right now is that this whole angle, DFE, is 50 degrees. So DFE, okay? That whole angle is 50 degrees, okay? And what they want us to find is just a measure of angle 2. They want us to find this angle right here, okay? But the thing is that this angle got cut in half, right? And so because it got cut in half, I know that each one of these two angles must be equal to half of the original angle. So that means that if I want to do half of it, I got to just divide by 2. So 50 divided by 2 is 25. Okay, so to make a long story short, this is 25. And think about why this makes sense, right? Those got cut in half. So half means that they're equal. And 25 plus 25 makes 50, right? So just notice that that's what you want. When we say bisector, we have to understand that we cut the angle into two equal pieces. And that's your job then, okay, is to make sure that you represent that by labeling the picture the right way. Okay, so we know a bisector means that it cuts into two equal pieces, and then after this we get to the distance formula. So let's talk about how to do this, okay? There are multiple ways to do the distance formula. One way that I'm going to show you is using the Pythagorean theorem, okay? So we'll do it that way, okay? Let's go like this, all right? What you're going to do is draw a graph, okay? And on this grid, we're just going to go plot these 2 points, okay? So let's start with this one. We'll do it in blue. We'll put both of them in blue, okay? 4, -5. So what this means is I'm going to go to the right 4 steps, and then that's the x coordinate, right? The y coordinate is the next one, and that tells me whether or not I go up or down. Since it's negative, that means I want to go down. So down 1, 2, 3, 4, 5, okay? So this point right here is the point for -5, right? Okay, now let's get the other one. Let's do this point, -3, -2. So -3 means I got to go left 3 times, and then because it's -2, that means I got to go down. So this point is the point -3, -2. Okay, now recognize what the problem wants us to do. It wants us to find the distance between these points. Okay, so it wants us to find the length of that line right there. Okay, so the way that we find the length of this line is by using this thing called the distance formula, which basically comes from the Pythagorean theorem. Okay, so here's what we really want to do, is we want to make a right triangle. All right, so to make a right triangle, I'm going to have to go straight down at a right angle, and then I'm going to go straight down at a right angle here to make sure that I can connect those 2 points and make a right triangle. Okay, now to get the formula, okay, we want to understand that we're going to call this A and B for the length of that side of the triangle. I'll shorten the axis a little bit there, okay? And then we got this length right here is our distance, okay? So to get the distance between those two, we need to take the square root of A squared plus B squared, okay? This will help us get the distance, okay? So notice all that is a substitution. I have to find the lengths of these sides of the triangle, okay? So let's slow this down a little bit and figure out how long does this side of the triangle have to be. Well, let's say I had to go down from -2 all the way to -5, right? So how many steps is that? That means I'm going to take 1, 2, 3, okay? So that tells me that A is really equal to 3. So I'm going to go change that into 3. Okay, what's the B? What's the B? What's the length of this side of the triangle? Well, let's see. I have to take 1, 2, 3 steps to get here, and then I got to take another 4. So 3 plus 4 is 7 steps. So that means this side is 7. So now to solve this, all I have to do is do 3 squared plus 7 squared. Okay, notice I just have to multiply those numbers by themselves. Okay, that's all it means to square something. So I got to do 3 times 3 and 7 times 7. So I'm just going to shrink this a little bit so that we can focus on our calculation. Okay, so 3 squared is 9, but notice it's all under the square root, and 7 squared is 49. So now I would just combine those two, and we get the square root of 58. Okay, we could do that in a calculator to get an exact value, an approximate value if we need, but the exact value is the square root of 58, so we would choose this one right here. We would choose B. Okay, I have a video on the distance formula. If you need to see more examples, you can watch that one, but there's one example for this video too. Okay, so just draw a little graph and count the sides. It's really not that bad once you count and plot the points correctly. So we see 23 would be a similar one, so you can go ahead and check the answer there. You should get the square root of 65. So again, draw a graph and figure it out. Okay, and now we get to this one with the midpoint of a line segment. Okay, and so there was more than one way to do this, so I'm going to do them both ways. The way that I had originally taught you guys how to do it, and we'll change it from there. Okay, so we had a formula for the midpoint. Okay, and the idea is if I change the comma to a different color, maybe that'll help a little bit. So that's a comma, and that's a comma. All right. So now look, the idea is that the midpoint formula looked like this. Okay, it had two coordinates, so it wasn't just one number; it was two different numbers. We have to add the x values, and then we divide by 2. Okay, but then we add the y values, and then we divide by 2. All right? So, for some reason I want to shrink the plus down a little bit. All right, there we go. So, this is the idea. You take your numbers, right, and you add up your x's, and you divide by 2. So, all we have to do is make sure we label our points right. So, let's go do that, okay? This is a -5, so that's the x coordinate. And the y coordinate I can see is right here is -3, right? So, the coordinates of this point are -5, -3. See? Okay, that's that one. Now we'll go get the other one. Okay, what's the coordinates of this point? All right, the coordinates of this one are 1, right? Because if I follow up there, I can see that that goes to 1. So that's the x coordinate. But the y coordinate, I follow to the y-axis, and I see that's -5. Okay, so notice those are my 2 points. All right, I want to find the midpoint of these two. Okay, so again, I told you I'm going to show you the original way, right? So to find the midpoint, then what I want to do is add my 2 x's. So I'm just going to take the numbers that I see. Okay, that's my x1 and my y1. That's my x2 and my y2. Again, I'm just adding the 2 x's. So I got -5 plus 1. Okay, and then divide by 2. That's it. Just put the numbers where they go. Now I'm going to add the 2 y values. Okay, I see a -3. So that means I'm going to write -3. Then plus y2. Okay, but y2 is -5. So we got to write it like that. And now we're almost ready to finish this up. Okay, so I guess I could put an equal sign here. So let's think about this. What is -5 plus 1? Well, -5 plus 1 means -4. So that's -4 over 2. Okay. -3 plus -5. Okay, you got to understand that that is -8. So looking at this, we can simplify it a little bit more because -4 divided by 2 is -2. And -8 divided by 2 is -4. So our final answer is -2, -4. And we can see that that's right here. Right? But there might be another way to solve this problem, and I'm going to show you how to do that too. Okay? So let's go take a look at what would make a lot of sense to solve this problem. Okay? We did it by using the formula, but we also need intuition in life, so don't be afraid to solve it that way. Okay? What I want you to think about is let's go look at all of these points. Let's start with this one, and we'll use process of elimination. All right? The coordinates at this point is +7, -7. So this only goes up to 5. So then 6, so 7 would be all the way here, and I'd have to go down 7, so that means this point is all the way over here, okay? And we can tell that this point is definitely not the midpoint of this line segment over here. It's not even on the line segment, right? So that's not the midpoint. So what should we do? Okay, we should cross out this option. That cannot be the answer. It can't possibly be, okay? So now we could go try the other ones, okay? Let's try another one. Let's try this point called -4, -2. Okay, so if I go to -4 and then I go down 2, look, that's this point right here. Okay, is that the answer? No, because look, that's not the midpoint of the line segment. So I could cross out this one too. Again, this point is not right here on the line. So I know that's not the answer. So now look, we already made this a 50-50 just by knowing that a midpoint of a line segment has to be on the line segment, right? So now look at this one, -3, +1. If I go left 3 and then up 1, that's this point, okay? This point, again, is also not on this line segment, so it can't be the midpoint. Okay, so now that I crossed out 3 of them, this must be the final answer. But we could go double check to see how that would feel, okay? Let's go to the left 2 and then down 4. And we see, hey, look at that point. It's over 3, down 1, over 3, down 1. So that must be halfway, okay? It's correctly placed halfway. So, again, use your intuition to solve these. You could use the numbers, or you could use the picture. Okay, but just get it right. Okay, in this case, again, you want to really line up all of the angles that are equal to each other. So notice that D has 1 arc and I has 1 mark. So that means I have to use one of these ones that's going to make sure that D and I are both in the same spot, okay? Then I want to make sure that C has 2 arcs and J has 2 arcs. So that means D goes with I, but C goes with J, okay? So you want to make sure that you can line all those up and set it up. For instance, like this one says that B goes with I, right? So what's up with that? Can that be true? That can't be true, right? This says that B is first, right? And that I is first. But we see B has 3 marks and H has 3 marks. So that can't be true. So cross that one out. Okay, what about this one? It says D and I. That's good. What about C and H? Uh-oh, that's not right because C has 2 and H has 3. So we'll cross out that one. Okay, so now we got a 50-50. It's one of these two. Okay, C equals H. No, that's not true, right? C has 2 and H has 3. So this can't be the answer either. So that tells me it must be D. Okay, and we could double check that D is equal to I. Those are both first. C is equal to J. Is that true? Yep, C has 2 and J has 2. And so the third one, B and H, also line up. So your answer should be D. Okay, so again, that was just the basics of triangle congruence. So if you knew that, you'll be able to get some points for that. Okay, this one's kind of self-explanatory. This one will be side, side, side. So if you need to do these ones, you might want to watch that video I have with the triangle. The fox says like a triangle face. All right, go pick that one. And you could review this a little more. Okay, there was 1 second geometry. So we would want to mark these 2 angles right here. And that would give us an angle, a side, and an angle. And so we know this one would be angle, side, angle in that case. All right, 29, in this case, again, it looks like we have another angle, side, angle case. All right, so again, watch out for the different possibilities and watch the video that goes along with that. Here we have a common side. So I'm hoping you guys can remember what we needed to do when there's a common side. It's similar to, vertical angles. It's a 1 second geometry. Just mark it, okay? So we see we have an angle, a side, and an angle. So we can see again that would be that we have to pick A for this case, all right? Okay, so now we get to our theorems, and I'm going to pause the video so I can draw these up really quick, and then we'll jump into the proofs. Okay, so to start this off, you guys will have a picture. There'll be a diagram on your actual paper, so if you didn't copy this down in class, you should copy it now. Okay, and we'll have this proof for alternate interior angle theorem. The difference will be that I will change these letters, and I will change these letters, okay? But the idea will be the same, and the theorem will be the same, okay? So we start off by saying that A is equal to C, okay? And the reason that that's true is called the corresponding angle postulate, okay? So I'm going to abbreviate a little bit for the sake of time, but please understand that this is supposed to say corresponding, okay? So these are corresponding angles, right? Sorry, I said that A equals C, but I meant to write that A equals B, okay? So I double checked that and fixed it right now, okay? So we got A equals B. Again, those are both corresponding angles, right? This is in the top right. Down here in this situation, right, A is in the top right, and up here, we have B is in the top right. So those are called corresponding, and because these lines are parallel, those have to be equal, okay? So again, this is a postulate, and that means it can't be proven, but this is like our definition of parallel lines, basically. Okay, the next thing that we want to see is that B is equal to C, okay? And this is something we proved a while back called the vertical angle theorem. Okay, so that's one that we can use to prove this theorem. And because we have everything that we need, notice that B is equal to C. So that means I can substitute in C for B. And if I do that, we've stated what it is we're trying to prove. So we can call this substitution, or we can call it the transitive property, which I'm going to call it that. You could also call it substitution property, and that would be fine technically. We'll take that. Like, it's acceptable. So here we go. This proof is now complete. Okay? But just understand that on the test day, you will have different letters. Okay? So the thing that I'm trying to get you guys to see is that the stuff on the right will not change. The only thing that will change will be the things on the left. So I hope if you guys understand that if I put W, X, and F, whatever, and I tell you to prove that X equals W, that you would be able to take it from here, right? Think about what is it that we would start with, okay? Well, I would use the new letters, right? And this time I would say that x equals f, right? And then after that, we'd say, okay, well now w equals f because those are vertical, right? And then after that, I would say, okay, well then x equals w because they're both equal to f, right? So I hope you guys can understand that you can use your notes. So try to do this so that you can show me that you're kind of following along with the proof, at least a little bit, all right? Get some partial credit is better than leaving it blank. Okay, so now we get to the next one, number 32, the triangle interior angle sum theorem. So for this one, we will need some parallel lines, okay? So I'll pause the video for a second so I can save some time here. So here we go. We have a triangle in the middle, so I want you guys to focus on the fact that we have a triangle here, okay? And no matter what triangle we have, we would always be able to extend one of the sides to make it a full line, and then we know how to make a parallel line that goes through that. So this is something that we could do to any triangle, right? We could always make these parallel lines work like this with any triangle. And so the way we want to start our proof is by saying that A equals X, okay? And the reason that that's equal to X is because of what we've been talking today is alternate interior angles, okay? The alternate interior angle theorem, okay? And that's why that's true, okay? But likewise, we also have that C is equal to Y, okay? Because those are also alternate interior angles, okay? So because of that, we're really close to being done with our proof already, actually, okay? The main thing that we need to observe is that these three angles, x plus b plus y, all add up to 180, okay? And earlier during the year, we proved a theorem, and instead of calling it the linear pair theorem, we called it the linear trio theorem, right? And we proved this so that we could use it to help us solve this problem when we needed it, okay? So now we're almost done. But again, after every step of a proof, you go back and think about what it is you're trying to prove, all right? I want to show that a plus b plus c equals 180, but instead I have x plus b plus y equals 180. So what you want to see now is that since a equals x, I can go plug that in for x, right? So now I could write a plus b, okay? But because y is equal to c, that means I could switch y into c, okay? And so notice that by changing those couple things, right, I now have the equation that I need. A plus b plus c equals 180, okay? And that reason is called the substitution property. So there we go. This proof is now complete. And we can see that it actually depended on the theorem that we used a second ago. So all of these proofs are kind of connected. And, you know, that brings up one issue is that I probably should have switched the order, right? So vertical angle should have been the first proof. So I'll definitely fix that on the test document. The first one that will prove will be vertical angle, all right? Now this is a 4-step proof, okay? But it's also one of the easier proofs that we can do here. So let's understand what it's asking us to prove here. Okay, so what we want to prove is the vertical angle theorem. And we want to prove, for instance, that A equals C. So to do this, we want to start off by saying that A plus B equals 180 degrees. And the reason that that is by definition of linear pair. Okay? And so I'm going to go draw on here like a little mark so we can see those two add up to 180. Okay? The next most common mistake I get is a lot of people say A plus B equals 180 and they say C plus D equals 180. Okay? And that's true. But it's not useful. Okay? What we want is something that's going to repeat itself twice. So we want to use B again so that we can solve this the right way. So what we do this time is we're going to say that C plus B also adds up to 180. Okay? So we'll write C plus B equals 180. And again, that's the same reason. Okay? By definition of linear pair. Okay, so we should notice that both of these things are equal to 180. So that means they must be equal to each other. So we have A plus B equals C plus B. Okay, and then we can notice that there's a B on both sides of the equation. So I can subtract B from both sides. Okay, and if I take away B from both sides, then we're left over with A equals C. Okay, so the reason that I could put those two together, those two equations, is called the transitive property. Okay, so we've seen that we did that last time too. And that just means when two things are equal to the same thing, that means they're equal to each other. Okay, and this last step that we did here was just subtraction. Okay, so we could see that we need the vertical angle theorem to prove the alternate interior angle theorem. And then we need the alternate interior angle theorem to prove the triangle angle sum theorem. So again, I'll change the letters. That will be the part that changes. The right side won't be different, but the left side will be up to you to understand how to read that. So I think you guys can handle that. Okay. At this point, we have an example of a planet speed. So let's try this one. So in this case, we know that we have to find the speed of the rotation of the planet Jupiter. Okay. We've done these in class a lot, and so we understand that a planet is round, okay, and that it spins around an axis, right, and so it's like 3D and everything like that, right? So we're trying to get this idea, and we know that if I have a point, right, that's on the planet and then it spins all the way around the planet, right, we know that it's going to be making a circle, right, and so the circumference of the circle is what we need, right? So this distance from the center to the edge is called the radius of the planet, and since we know every planet spins around in a circle, right, I can find the distance that it takes this planet to spin around, okay? So we want to talk about our definition of speed, right? Speed, okay, we'll say is equal to distance traveled, okay, divided by the time that it took to travel that distance, okay? So I'll abbreviate that with distance traveled over time travel, okay? So the next thing that we have to think about is what is that distance and what's the time? Well, we already know that the time is going to be 10 hours, right? That's how long it takes them to do a lap around Jupiter, because Jupiter takes 10 hours to turn around, right? So that's what we mean by the length of a Jupiter day, right? But we want to find how long, how far would somebody standing on the surface of Jupiter be spinning, right? If we were on this part of the surface anyway, we might not have a solid surface. So in this case, we would have to use the circumference because we realize that this shape is a circle, okay? So the distance around a circle uses this formula that's called 2 pi r, okay, where the r is the radius. So again, this is what we need to have. We need to have the distance is equal again to the circumference, okay? And the circumference is then 2 pi r, okay? So what we're going to do is go substitute in this value that we need right here, okay? So we'll have this all divided by 10, but on top we're going to do 2 times pi times the radius, okay? And what's the radius? Well, the radius of Jupiter is 43,441. So what you have to do in this case is use this in your calculator. And this was something that I think we have been working on for a while. I tried to really make sure that everybody could do these during class. So if you have a calculator, this is some calculator math. Okay, so I would do 2 times pi times 43441. And I would be looking at this number in my calculator. So I'm just going to write a little bit of everything so you guys can see what I have. So far I got 272,947.852. Okay, but when I divide that by 10 now, we'll have our final answer. Okay, and I'll just move this over a little bit to get the final answer, which would be 27,947.852. 0.79 miles per hour. All right. So again, do that in the calculator. That's how that works. Okay, so this video, we just made it to the end of the practice benchmark that I gave you guys for homework. That was this one. I did pretty much every single example. So if you guys want more examples, I might make another one depending how many people ask for it, okay? But for now, this will be the way that you start. Again, I'm going to point out on Google Classroom, if you guys take a look here, the Practice Semester 1 benchmark, I gave you guys a bigger version with way more examples. It's all digital though, so I didn't print this one out. But if you want to study any one topic, you could look at it a little more and get more examples, and all the answers are there too. So, you know, take a look at this. The only thing I'm going to say is that there's some problems that are on this practice that are not on the actual test. So if you don't see them on the practice version that I gave you, then those ones wouldn't be on there. So notice like all these ones in between 106, like 196, none of those are going to be on the test. So from 96 to, you know, 126, pretty much none of those are going to be on the test, except for this idea of circumference in that one problem. All right. So there you go. There's also more practice from Unit 2, and you guys could do that too in the case that you need more practice. All right. Good luck.